Hello students, welcome back. In today's class we will learn about pressure vessels. What are pressure vessels, how pressure vessels are used, and why pressure vessels, what are the main factors related to pressure vessels. Pressure vessels is a completely a big big chapter or big topic, you may say, where at least we need 2 to 3 classes to complete. So in today's class it's a small introduction, or you may say small go through the pressure vessels. How does the pressure vessel controls, and what are the factors we incorporate while designing a pressure vessels. First of all, what are pressure vessels? The most question is what is pressure vessel and how is pressure vessel defined? Pressure vessels is defined as any sort of vessels or any sort of container which could hold certain fluid pressures. Any container which could hold a fluid pressure is termed as pressure vessels. It can be a metallic container, or it can be a plastic container, it can be a polymeric container, or it can be anything. So it actually depends. Depend on the pressure on the material of what you are using. Now, so what type of system you are using to design a pressure vessel? So everything is related to ASME, that is American Society of Mechanical Engineers. They are the person who directs everything, each and everything of pressure vessels. So you have to follow the guidelines. Now, before going to the depth of pressure vessels, as well as the introduction, as well as the go through of the pressure vessels. So let us understand why pressure vessel is so important for which ASME, as well as regulatory bodies like other regulatory bodies of other countries or continents are very precise on this pressure vessels, because to understand the factor, pressure vessel not only hold pressure, fluidic pressures. The fluid may be LPG fluid, or it may be a fluid of medical purpose, or it may be a fluid of food purpose, fluid for food purpose, like for example a cold drinks bottle, or it may be your medicine which should be pressurized with some sort of gas. So everything is related to an amount of pressure, that is you have to hold the pressure, you can't release the pressure, you have to hold the pressure and pressurize it, because if you get a pressurized body, it is impossible, it's very difficult to temper the body, which is very difficult to destroy the body, because due to pressurization there is a outward force, radially outward force acting on the body. So we'll learn about it in coming session today. So what are the pressure vessels main concepts? That is, one is hook stress, one is hoop stress, and one is hook stress. So one acts in the circumference of the structure, and one acts to the longitudinal of the structure. So how it works, let us understand in a few simple way. Let us go back, take one pen, let this be okay, screen and white screen. So if you consider a pressure vessels of this one, the pressure on this circumference, acting on this circumference, will be your hook stress. Now the longitudinal stress works on, let's go back to the screen again, white screen. Let me draw it. Just give me a moment. Okay, the pressure acting on the entire circumference is termed as hoop stress, and the pressure working on this longitudinal way out is termed as hook stress. Fine. This circumference is connected to hoop, and this is connected to hook stress. Now, how it accumulates. If a pressure, if it's a body is highly pressurized, that means a force is acting on the either side from the center to every point of the circumference. That means it's a pressurized. That means you can't smash the bottle, like as you can see in the in our cold drinks or soft drinks bottle. After releasing the pressure or after opening the cap of the bottle, when you reinsert the cap or retighten the cap, the bottle get you could smash the bottle. But before, while without opening the cap, the pressure, the fluid inside it is pressurized. That means you can't smash the fluid because it's completely pressurized. So this is what happened. Okay, let's go to the unwhite. So we have learned about water pressurization. What we could actually get one idea. One is working on the circumference, one is working on the longitude. Now they have been divided in two categories. One is your thick cylinder, one is on a thin cylinder. So scientists came up with a solution how to determine this thick and thin cylinders. So why it is so necessary for it? Because to hold a pressure, sometimes you need to increase the material too much, or you have to decrease the material too much. So, or in other words, you are holding an enormous amount of pressure. That means the border lining of the pressure or the circumference of the pressurized chamber should be maximum. So how much it should be maximum? So it have to, so for to understand the maximum and the minimum amount of thickness of the body to be assigned, the scientist of ASME has gone to, as well as the other regulators including ASME, they have started they started some features like what is thin. They've started on feature, that is including thin and thick. That means they will make it understand which one is thin and which is thick. So it's entirely depends on the application. So scientists has told that they have determined it in the simplest way and the simplest form. So you could so that people can understand it very well, what is thick cylinders and what is thin cylinders. And after determination of this thing, everything the problems get very much easier to understand for them. So let us understand how it works. Okay, my right click, and it's going to the white screen. Okay, so let us consider one circumference, another circumference. Okay, this to be the thickness T. This is the center of the circle, and this one to this one is di. Just a minute, let me complete this thing. Okay, let us understand the thing what I have drawn. This is one to make you understand in the simplest way. This is your let me find out visible. Okay, this is your the thickness. Now what is the thickness? This is a cylinder. Okay, a cylinder cross section. This is a cylinder cross section. So this is the internal diameter of the cylinder and this is the external diameter of the cylinder, and is the thickness which is d naught minus di, that is d outside minus d inside, that is t. Okay, the thickness of the cylinder body. Okay, understood? Now this is the t is the thickness of the cylinder body. What happens? As per the ASME consideration, we could take in account that the ratio of di by t should be greater than 15 to consider a thin body. Okay, so let us take one example. If the diameter of internal diameter is 2 and the thickness, internal diameter is not 2, internal diameter is 15 and thickness is 2, the what comes? 15 divided by 2, that is 7.5. That means it's a thick cylinder. It's a thick cylinder because we know for thin cylinder the ratio should be greater than 50. Okay, now to understand the perception in a much more greater way, if di that is the internal diameter is 30, for example 30 or 36, and the thickness is 2, so what is 36 divided by 2? It's 18. So it will be a thin cylinder. Again, the internal diameter is 36. Okay, and the thickness, let me take the for how much shall I take? Let me take the thickness to be 5. So how much it will be? 5 divided by 36, 36, that is 6 times 6.1 or something like this it goes. Okay, 6.12. So it is less than 15. That means it will be a thick cylinder. So this is the criteria for thick and thin cylinders. If you have any problem, you could ask me again. So this is not the first and last class. This is just the first class. This is just overall class. The problems will be solved in your coming classes. If you have query, you may ask me. So let us go onward. Okay. So we have learned about what is thick cylinders, what is how we consider thin cylinders, and how we consider thick cylinders. So we have to, first of all, we calculate about the thick cylinders, and in consideration of principal stress and strain. So after that there is some laws. So the thickness T, as I have told you, as you can see over here, it is written over T as well as the T and T. This T depends on the few factors, like there is some ratio of, there is some equations made by our scientists and scholars. They have termed as Clavinos, or you may go for Bryan's equations, or you may go for other equations, the Lami's equations. So everything is related to certain amount of equations. Why? Some have considered a completely closed chamber, some has considered a semi-closed closed cylinders, or anything. It can be anything. So you can't say that you have to determine T, that is the thickness of the cylinder, in just with one way out. So you have to determine in all way out and find the best suited for my best application. So in coming classes we learn about what are Lami's equations, what is Clavinos equations, what is Bryan's equations, and how does it works, as well as we learn how to derive how a thick cylinder is related to a thin cylinders, and how can a thick cylinder can explain every criteria of pressurized pressure vessels or pressure cylinders. Oh, okay. Now before going back, pressure vessel doesn't mean that it should be a cylinder. It can be a cylinder, it may not be a cylinder. As you can see, it has been considered in terms of cylinders, but if you go back, it has not been considered in terms of cylinders. So the cross section can be a cylinder cross section, or it can be a rectangular cross section, triangular cross section, or anything. So stay at home, stay safe, as well as your classes, you'll get your video classes, video lectures in coming classes. Have a nice day. Bye bye.